Hi there. I hope you're all having a very nice day. And I'd like to say a few words about ranking data in Microsoft Excel with a bit of a twist. First, um, let me cut to this demo file courtesy of the Spreadsheet Guru website, which consists of staff data for a hypothetical company. Now, you'll note the salary field. And what I want to do initially is simply rank the salaries from highest to lowest. Now, you're probably familiar with Excel's rank function, which will be written in this case the following way. All the fields in this data set have been range named. So I can reference the salary field twice. The second reference to salary indicates the individual salaries that are being compared against the entire range of salaries. And you see the formula as it's been written, and there are the respective rankings of all the salaries for all the members, the employees of this company, which consists of about 900 plus members. However, that's not ultimately what I want to do. Rather, what I want to do is rank the salaries internally by department. That is to say, I want to determine the largest salary for IT, the largest salary for finance, or the seventh largest salary for sales, etc. So that requires a different formula. In this particular case, count if S. Count if S. And I'm going to write it in the following way. We're, of course, operating under a time constraint, so I can't explain the formula in great detail. But in this case, we're dealing with two batches of arguments. The first case, we are going to establish the department as one of the criteria. And again, the second instance of the department refers to the individual records in or rows in the department column. And the second criterion refers naturally to the salaries which we want to compare. Now, here's the tricky bit. I'm going to write a string concatenation formula, which looks like this, which bottom line represents we want to compare all the salaries that are greater than each of the individual salaries that are enumerated here, in addition to the department. That is to say, all the salaries that are greater than this figure in the IT department, all the salaries that exceed this figure in the finance department, and so on. And I'm going to add a +1. Why a +1? Because if I identify the largest salary in the department, well, we're looking for greater than. There is no salary greater than the largest salary in the department, and as a result, it would yield a ranking of or count of 0. That doesn't look right. We want to add a 1 to every ranking so that the highest salary would present a ranking of 1. In any event, there are our internal rankings by department. Now, once I've gotten this far, I'm going to turn to a pivot table that I've already constructed via the pivot by function. This is a formula-driven pivot table, and it's over here. And okay, and there's the formula here that you can note and copy. You can freeze frame the video and jot this down and play around with it. What this formula, what this pivot table is doing is ranking each salary niche by each department simultaneously. Right here, I'm viewing the top 4 salaries for each and every department simultaneously. And I can modify the desired number of ranks right up here. If I type 10 here, I'll view the top 10 salaries for every department. If I enter a 6, I'll restrict the results to the top 6 by department. This is all made possible by the internal ranking that we constructed in the actual data set. Notice that this pivot table formula, the formula is written right here in cell B7, and here's the formula as it's been captured by formula text, filters the ranks. That is the value that I enter in cell A1. Salary rank less than or equal to A1. So I type 11, for example. All right, the top 11 ranks are filtered, and so on. So I hope you find this little presentation instructive and productive. And I hope you have fun with the formulas and have a great day.